let's solve insertion sort problem. So in this insertion sort problem, we have given an array like this: 5, 3, 4, 6, 8, 1. So this is our array, and we have to sort this array using insertion sort. So what is insertion sort? So basically, in this insertion sort, we will start from one element and we will iterate the whole array. So first, let's just do step by step iteration. Then you are able to understand what we are doing in insertion sort and why it's called insertion sort. So we will check where 5 is sorted or not. So yes, 5 is sorted. So now we are not doing anything. Now let's expand our array. Okay, so 3 is not its sorted position, so 3 should be over here and 5 should be over here. So now we will swap these two element, 3 over here, 5 over here. Okay, so let me write by step. So just over here. So now we will swap these two element, 3 over here, 5 over here, 4 over here, 6, 8 and 1. So we have swapped these two element. Now it's completed. Now we will check for this. We expand our array. We have done for this two element. Now we will doing for 3 element. So 4 is not in sorted position. So what we going to do is we will append our 4 over here between 3 and 5. Okay, so we will append our 4 in between 3 and 5. So how we will going to do this? So we will check whether if this is our ith position, so I minus 1, we will check while I minus 1 is greater than I position, till then we are swapping element and then we will append. So what is this mean is we will first of all swap these two elements. So 4 come over here, 5 come over here. So now it's in its sorted order. Okay, so we have sorted for this. Now we will check for the iterate to fourth element. So 3, 4, 5, 6, 8 and 1. So as you can see over here, 6 is in its current position, and suppose we have 2 over here, and let's modify our array little bit, 2 over here. Okay, and suppose our this is not a 3, this is 1. Okay, so instead of 3 we are dealing with 1, so we can append our element 1 over here. So that's why I have taken this 2 and changes 1. Okay, now how we will going to append this one in position of 4? So what we are going to do is we will check we will check its previous element. So 6 is greater than 2, so we will swap these two elements. So 2 come over here, 6 come over here. Now we will check with 5. So 5 come over here and 2 come over here. Okay, now we will check for 4. So we will swap these two elements, 4, and now we know that this is in sorted position. Now it's reached its position because 1 is less than 2. So we know that 2 is in its correct position. So that's why we have sorted this array. Now what we are going to do for this one, we will again check whether 1 is greater than 1 is greater than 6 or not. If not, then we will swap. So 1 come over here, 6 come over here, then we will again swap. So let me just rewrite this array again and doing for over here. So what we're going to do is, first of all we will swap 1, 2, 4, 5, 6 and 1. So let me rewrite 5 as, so we are going to swap these two elements. So 1 come over here, 6 come over here. Now we will swap this two element because it's not, 1 is in correct position. So we will write 1 over here, 5 over here. Now we will again check for 4 and 1. We will swap these two element, 1 over here, come 4 over here. Now we will again swap these two elements. So 1 come over here, 2 come over here. So now we have a sorted array. So this is how we are going to solve this problem. So we will start from 1 to, we will go to till in the length of the our nums array. Okay, so this is we are doing an operation, and for swapping the each and every element we are doing one we are doing swap, sorry, where is where is everything? Okay, over here. Sorry for this. Hmm. So what we're going to do is we are swapping each and every element n time. So over here we have swapped n time. So our and we are performing for n time. So our time complexity become n into n equal to n square. So our time complexity become n square in this problem. Okay. So this is how we're going to solve this problem. And in a base case scenario, if we have a sorted array 1 2 3 4 5, so our time complexity only become big of n. So in base case our time complexity become big of n. In worst case our time complexity is n square. So this is the problem, and now let's code this problem, code this insertion sort. So let's code it up. So first of all we are getting an input, so nums equal to uh, int. Okay, so by using this we are getting input, so we just passing this to our insertion sort insertion sort function as nums, and it will return us output. So let's create an insertion sort for function insertion sort, which will take nums and return give us return nums. Okay, so this is our. Now what we're going to do is we are iterate through whole array, and each time we are skipping one element. So so that we are starting from the 1, then we are iterate for 1 and 2, then we are iterate from 1 2 3 4. So so how we are going to solve this? So we will let's create a for loop for I in range of n of nums. So which I candidate I what is this I is the position which we are currently end of the node. So initially 5, then 5 and 2, then 5 2 4, 5 1 4. So this is how I our iterate. And what we're going to do is we are swapping elements. So in first case we are swapping 1 and 5. So while I is greater than 0, greater than 0, and nums of I. So nums of I is means we are currently over here, and 1 is greater than if nums of I means this element is less than nums of I minus 1. So we are iterate through the array. Okay, and we are just swap these two elements. So nums of I minus 1 and nums of I equal to nums of I and I minus 1. Okay, so by this using this we are swapping these elements, and we are iterating through till we are getting, and then we are decrement our I. Okay, so let's run this code for any compilation error. Sorry, so let's give it a array, random array. Okay, so this is giving us correct output. Okay, so thank you for watching this video, and this is the pretty much code for this, only 4-line code. So and you can try it by your own, this code.